The smart filament runout sensor. What is this thing? And how can it possibly save your printer from total catastrophe? Hey everybody, how's it going? This is Patrick with Stacking Layers. Today's video is going to be all about the Bigtreetech SFS2 Smart Filament Sensor version 2. Bigtreetech was really cool to send me this thing to review it, but I figured, of course, like I normally do, I'm not going to just review, but I'm going to go over a deep dive of what it is and how to get it set up. So if that's something for you, follow along with today's video. I also want to give a big shout out to PCBWay for sponsoring these videos, but a little bit more about that later. So what are these things? What is a smart filament sensor? What makes it smart? Well, I've removed the screws, so let's open this up and you can see what's going on inside. In my opinion, it's a very elegant and simple solution to give a lot of functionality here. So what am I talking about? Well, this thing packs two pretty simple sensors. The first one you may notice right off the bat is this little guy here, the black and white part. That is a standard micro switch. Same thing that's used in a standard filament runout sensor. Also what's used on most end stops. All it does is when the when the little switch is clicked, it is in this configuration set to send a signal out when it's clicked. And this one gets clicked when there's no more filament. So when the filament runs out, the switch gets connected, sends a signal, hey, no more filament, and it does whatever you have programmed the firmware to do. The next sensor is a little bit more interesting here. This is an encoder. It's a rotary encoder. So as you can see, you got this little wheel, looks like a gear spinning around, and it's got these notches. And what happens is every time one of those notches passes in front of this guy here, those two little silver tabs, what it does is it blocks and allows light back and forth to come from underneath this little infrared diode, light diode, or LED, that's sending light out. And as it passes through, that light is able to meet with this sensor, which goes through here and again sends a signal out to your board saying that it's moving. So what's going on? Why is that smart? Well, 'cause if you notice, I mean, maybe you don't notice, but all that's here is a little circuitry to get the signal of light pulses to come out as a signal. That's it. There's no programming needed for this thing. It comes ready to go. There's no MCU or anything like that, no firmware needed. But what it's doing, what makes it smart, is that as the filament is going, as you can see here, when the filament's moving, that rotary is moving. So as the machine is asking for, say, 10 millimeters filament, it moves 10 millimeters and stops. That's going to send a pulse saying, yeah, that's how things were working. Everything is moving like it says. And of course, if you run out of filament, then this will switch, immediately sending a signal, no more filament. But that's not how it will save your machine. How can this thing save your machine? Well, let's give you a scenario. First off, while it's moving, think about if there's a jam in your nozzle. If there's a jam in your nozzle, a standard filament sensor is not going to say anything that, your filament's gone or messed up because it's still there. All good. Filament's in the position it needs to be. No problems. So you don't get an error. But now we add this part about it. If there's a jam, that filament stops moving or doesn't move like it's being told to. So say it's told to move 5 millimeters, but it only moves 1 millimeter or so. I think with this one, I think it's supposed to be 2 millimeters is the minimum it can do. But say it says to go 10 millimeters, it only goes 5. Well, it's able to recognize that that's going on and to send the signal. So it can actually help you without your machine grinding away at filament, trying to push something through, and pause your pause your print, or however you have your macro set up, or whatever you want it to do. But the real catastrophe that this can help you prevent is the other side. Where's the filament coming from? What if you get a tangle on your spool? That is a bigger problem. I've seen some pictures, I don't know if you've seen them, but I've seen where people have had no sensors, or at least only had a filament runout sensor, and because of a tangle on the spool, the machine is strong enough, the extruder is really strong, believe it or not, and it can pull that entire spool off a rack. If you have them up on a shelf or something like that, it can pull it down off the rack, break screws that are holding things together, and slam it down on top of your machine. And I've seen things as bad as full 3D printers getting thrown to the floor because of the fact that a tangle has happened on the spool where the material is coming from. But with this thing is that when that tangle happens, it starts putting pressure, and it's going to start not letting the material move as good as it should be, which should relate to an incorrect motion. And so the machine, when tuned right, should be able to sense that there's been a stop, even though it's told it to. and then maybe a little bit later it'll move again when it wasn't told to, or it didn't move in the right manner. And that's how it can save your machine. It can tell you that there's something wrong with the motion of the filament and trigger a code. So that's why I think these things are brilliant. Now, enough of that. Let's show you how do you get these things set up. So let's get this back together. Of course, first we're going to have to plug it in. I'm using the Bigtreetech E3 like I've been doing with most of my tutorials right now. I'm not going to put the screws back in here just to save time, but of course do that, or don't take it apart at all. If you're curious, you could look inside. But it snaps together pretty nice and easy. Now there are 4 pins on this sensor. One is power, of course. One is ground, because like I was mentioning, the LEDs inside need power for that. There's also a little indicator LED that lights up when active. And then the other 2 pins are your sense pins. You have the filament runout and the motion sensor. It does come with this. Hopefully I can get that on camera. Let's see. Comes with this little connector here already set up for you, so you don't have to do any crimping. But because I already have this plugged onto my main machine that I've been testing this thing on, I've gone ahead and made a fake harness. But the reason why I did that is because you'll notice these connectors or the wires are in 3-pin connectors, but there's only 2 each, and they're in different configurations. There's a reason for that, and we're going to go over that now. So before we show you the pinouts on this board and why they're in this configuration, I'm going to show you what is going on. So like I said, you have power and 2 sense pins. The power on these are red and black. The red one is, of course, 5 volts, and the black is ground. They kept it pretty traditional there with color schemes, luckily. The blue one is connected to the switch sensor. So the blue is the filament runout switch. That's the one that's going to trigger when you lose filament. The green one is the motion, the rotary sensing pin. So that's something to keep in mind here, because we're going to be installing it on Klipper, but on Marlin, it does work on both. But with Marlin, unfortunately, you can only choose one of the features. It doesn't allow you to have both at the same time. So if you're using Marlin, you're going to want to use the green one, which is the motion, because if you do, you can still get the filament run out kind of idea to the controller board or to the firmware, because basically if you run out of filament, the rotary is going to stop moving, right? Because there's no more filament to move it. So it'll trigger the same kind of thing, that something's wrong, basically. And you can set up, typically the macros or the trigger code that you use is for a pause. So you can go ahead and swap or redo your filament or fix what's going on and continue printing. So that's something I needed to point out, is if you're using Marlin, you can only choose one of these. And if you're using Marlin, because you can only choose one, you're going to have to repin your things. Or I guess you can still plug them all in, but you just won't use the switch one. But, to keep a plug available, what you would do is move the power over to this empty one here and not even use this one. It's up to you. You can still plug it in, but it's not going to be able to be used. So you would have power, ground, and sense pin in this configuration. And it really, of course, depends on your board. So let's go quick and look at the pinouts for the SKR Mini E3, so you can see what I'm talking about with where to plug these things in. So here we are at the pinouts. This is something, if you're not familiar with, most controller boards, especially all of Bigtreetech's boards, they have a pinout file. This shows you basically what all the different pins on your board are doing, or at least most of them, all the important ones. So today we're going to be using the E0 stop, that's this group here with 3 pins, and the power detect. Now I know it says power detect, but we're going to be repurposing that to use the runout sensor. So sorry, the motion sensor. The runout sensor is going to go on the E0 on this board, and runout is going to go, sorry, I'm saying that wrong again. Runout on E0 and the motion on the power detect. And the reason why I chose it to configure it that way is if you look down here, this tells you what pins do what. So here's the E0 stop pin. And the first one is PC15. So that's the pin that we designate to listen for the signal. And then you have ground and 5 volts. Whereas the power detect has the PC12, so again, where it's listening for the signal, and ground, but then it has this NC. NC in this type of configuration, when we're talking about pins, normally means not connected. So there's nothing there. That pin is just sitting there to look pretty. So the way that these plugs are configured, we have the green and the black going to these two, and then we have the blue on PC15 and the red on the +5. Now, I said if you're going to go to Marlin and use the motion detection, you're going to want to move the red one next to the black, so you have the green, red, black, and then use just the E0 stop, because that gives you all three of them. Okay, hopefully that makes sense. If you have any questions about that, definitely go down in the comments, let me know. But if you're using Marlin, move the red next to the black, so you have green, red, black, and use it on here, E-stop. Okay, but we're doing Klipper today, so we're going to be plugging it in to power detect and E-stop. So let's go over to the board and show you that. So here we go. Like I said, the 3 pins. Now make sure if you ever do anything, anytime you do wiring or anything, unplug. You see I'm not plugged into anything. Don't leave your board powered up when you're doing plugging and unplugging. That can damage stuff. So we'll get this plugged in there to the power detect, and then we have that one on the E-stop. These are brand new plugs. I just made these for demonstration, so they're a little tight. So there you go. All right, so that's how it's going to go if you're using this with this specific board on this. Now, any other boards, you don't have to use power detect or the E0. These are available in 3-pin configuration, so that's why I'm using them on this board. But if you have, for instance, you're using a BL Touch or some sort of thing, and you have your Z end stop available, you can repin if you have only these two available, or you can do other things to use that. Or if you're using sensorless homing, for example, and a little bit more advanced for homing stuff, and you have these other pins available, you can use any of the end stop pins for these connections. You can even have where you rewire these plugs and have ground and 5-volt on their own separate pin somewhere else on their own plug, and then have 2 sense pins on these. So I recommend use them on end stop style pins. On this board, the power detect is plugged in virtually the same way as plugged into the MCU here. It's plugged in virtually the same way. So it's got like 100K resistor in between the sense to prevent over current going through. So they're still compatible. But end stops are actually the most protected when it comes to sensing signals. So they're good to use if you have them available for other options like this. So for instance, I'm going to be using it on my Huracan when I do my demonstration, and I have it plugged into the E0 and the Z end stop, since I have a probe for my Z homing. So that's one of the options. If you're using this on a Huracan or like a Manta board MP4, which is in my, M4P, which is in my Huracan, then you don't have, if you don't have that power detect, you can use other ones, okay? So I just want to point out, with this board, this is what we're using. Hopefully you understand that. So let's get that configured. But before we do that, let's hear a little word from our sponsor. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWay. PCBWay isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machined parts through CNC machining and so much more, PCBWay has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWay takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWay offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWay services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWay for sponsoring this video. And now let's get back to the video. Okay, so let's get this configured. First things first, of course, we need to make a profile for that. And like I normally recommend, I'm going to be setting up a separate configuration file just for this sensor. So to do that, this is in main cell. If you have fluid, it should look very similar. You're going to want to go into your machine settings where you have your configuration. So create a file, and I'm going to label it just SFS2 because that's it. That's what it is. And the important part you want to put is .cfg. That is going to be a configuration file, and we create. And then if it didn't open up automatically, you can go ahead and open it, find and open it. And as you can see, you're presented with a blank configuration file. Now, of course, the Bigtreetech website, or sorry, their GitHub has a pre-configured example for you. So we're going to keep this as simple as possible. Copy that out, come back in and paste. That's it for that part. Now what we have to do is tell this configuration what pins to look for. And that is these pins here. You have the switch pin on both of these, but you notice it says filament motion sensor and filament switch sensor. So that's the important thing to pay attention to, which one is which. So with the switch sensor, we're not using GPIO pins on this board. GPIO is typically like if it's plugged into the Raspberry Pi or something that has that type of a setup. With the Bigtreetech Mini, like we saw on this board, they use PC15 and PC12. So we're going to use PC15 on the switch. Oops, can't do it there. Do it here. So PC15. Then down below, for the motion sensor, we want to get that one, which again, we'll go and check to make sure that is PC12 that we're using. Oops, I keep going to that. Let's go here. Get rid of the GPIO and all that and do PC12, right? Did I remember that correctly? Yes. Okay, and that's it. That's all you actually need to do. Now, I do want to explain, though, of course, what is going on in here. So pretty simple. First one starts off with the filament switch sensor. So that's saying that when the filament sensor or that specific pin gets a high signal, so when the runs out, the switch connects it. And so when it gets that signal, it's going to, well, here it's saying run out false. But so it's not going to automatically pause. It's going to go next to the run out G code, which is just a pause. They've set it up this way is because some people will actually have more than just one thing happen in their pause feature. So instead of just pausing immediately, they can run through a macro. And what a macro does is allow you to stack up things. So this one is actually allowing it to run a pause feature. So it's going to do whatever you have in that part of the file. Typically what it does, it'll lift and move the head to like a safe spot. Is what's kind of like standard programmed into your machine for Klipper here. And then once that pause feature is finished, it will do this one, which is M117. And that is basically send a message to the screen. So this is something to give you an idea of, well, why did you just pause? And it'll actually tell you filament switch run out. So it'll let you know which thing is done. Then the next one is the insert G code. So that's when this switch goes back to its previous state. It'll go and run this message saying that the filament's been entered. Personally, I don't need that, but I wanted to point it out is because you can actually cause this to do other things. So if you have an extruder, for instance, that if it was truly ran out of filament and your extruder is set up to have a load option, you can program this to run that load macro. And so when you put your filament in, that switch gets triggered and it'll start feeding the filament back to your printhead. So you can do a lot of things with these. I do want to point out, if you notice the run out after G code and any of these, anywhere where you have a G code, there's an indent for the next line, right? That indent is important. Anytime you have a G code, basically it's going to be running, like I said, in sequence as you write these things. You have to have an indent, otherwise it won't work. So I do want to point that out. If you've copied and pasted and it looks like like that or like that, it's not going to work. You do need to have at least 2 spaces right there. Okay, so make sure that's there. Personally, like I said, I don't use the insert because I don't have any type. It's a direct drive on my system, so I just push it right in by hand always. So you can just comment that part out if you don't want to use it, just by doing that. Where those comments are don't really matter as long as it's ahead of the line. So Klipper will no longer look at those. And then the next part is the motion sensor. So again, it's starting to, or it's using this pin to detect what's happening. The motion sensor has a little bit more because it's motion. It can actually detect a length of motion. So it's using that rotary to calculate how much motion has happened. And that's important to know because here they leave the most sensitive that it can be. You may want to bump this up to 3 or 4, something like that, to make it a little bit less sensitive. It depends on your thing. I left mine on the 2.88 because it seems to work perfect. And this is actually really good motion. The older style smart filament sensor, the version 1, I think was like a minimum of 7 millimeters before it would trigger anything. So what's happening here is saying that on this switch, if I don't have any activity, and I've asked for at least 2.88 millimeters of motion, and I still haven't had any activity within that motion, trigger the alarm. So if you have 10 here, it's not going to trigger any alarm until the filament has tried to move 10 millimeters without receiving a confirmation signal of motion. Hopefully that's making sense. The next part is you need to know which extruder. So this can be done if you have multiple extruders, of course, so you can tell it what extruder is it listening to. So, when it's given a command to extruder 1, if you have an IDEX machine or something with multiple extruders, then you have to tell it which one is the sensor on. And that's what that part is. Again, we're using false on the pause on runout because we want to do a little bit of a G code on there. And that extra G code is just because we're allowing the extra part of this here, putting a message. So if you don't care about a message, you can put this to true and just completely get rid of this whole area if you wanted to. I like it this way. I mean, that's how I would do it. So, it's pretty common. It's more or less, again, just giving you an idea of what a simple setup can be. You can get these things really complicated. So you can, if you have somehow programmed it to set up to send you a message, you can even have, because there's ways of getting Klipper to send a message to, for instance, Discord or something like that, and you'll get an alert. Hey, the message, the filament ran out. So it can pause and then send that message, and then put a message on your screen and flash lights. That's what these G codes are. You can stack up all sorts of different things in the G code to really get it, really cool and customizable. Again, same thing with the insert. Whatever you want them to happen when you start showing motion again. So when you put that filament back in, it triggers the motion, and that's saying insert, and it'll start running through whatever G code you have here. So, if you want to have a little audio file play with people applauding, there you go. You can literally do whatever you want with these things once you get into the programming side of stuff. We'll go over G code once I get a little bit more, I guess, in-depth understanding of it, because it's a little bit more complicated than this. When you come to setting up what these macros are doing, these are macros, this pause. So yeah, we'll do another video of that down the line. I do want to show you. It's really fun what you can do with these things. But for now, like I said, I'm just going to be getting rid of those because, again, I don't use them because of the way I have things set up. It's up to you if you want to use it or not. Not necessary to the functioning of the alarm part, the important part. So that's it. That's your configuration. There's really nothing else you need to do here. Of course, you want to save and restart because that's going to implement the new thing. But before we do that, because we're using this as a separate configuration file, we have to go over to the printer configuration and make sure to include that in there. So we can enter it wherever we want. If you follow my previous video with the input shaper, you'll know why that's up here on the top. I'm just going to go down below the next thing. So basically you want to keep your includes at the top. This just keeps it nice and clean. Doesn't really matter where they are as long as they start before you do something down below that requires them to function. So that's why it's good to just leave them at the top. So we're going to do that. You want to put the brackets, and then you type include, and then a space, and then the name of that file. So we named it SFS2.cfg. And that's included. So now what you're saying is include everything else that was inside that file we just made. So there's where you would save and restart, because now we're saying implement that. So when you restart, the printer configuration file reads everything that's in those includes. It's initializing. And because that include was in there, it also pulled all the information here into the printer configuration file in the background of the startup sequence. So it doesn't actually put it in there, but yeah. This is the first time hearing about that stuff. That's why I'm explaining it. It gets a little confusing, but in my opinion, this is a cleaner way of adding features to your machine. Because if you decide you don't like this instead of having to go through your printer configuration, finding all the stuff that you had that you messed with here, and finding and deleting it or commenting it out, you can just come to here, delete that file, and then go to the printer configuration, delete this one line, and it's back to the way it was. Much simpler, easier to find, instead of having to have it, like down in here. So that's why I use and recommend using includes. So yeah, that's honestly it. I'm gonna go ahead and plug this back into my machine and show you how I have it set up, so you can just see what's going on with that. I'll be right back with that. So this is how I have it set up on my machine. I really went the lazy route. One thing I didn't point out is this actually can function either direction. So there is no special direction it needs to be mounted. So depending on how you do it, because there's the 3 different mounting bolts underneath, right? The heat inserts. So depending on where you can mount on your machine, it's good. You can do it however you want. If you want the text to be straight, of course, that's up to you for aesthetics, but it's not necessary. So I've mounted it just simply to here where I had the old motor on, since I have a direct drive on this now. And the filament is in, and so it comes from the spool and then goes out. I do recommend using a Bowden system if you're using a direct drive. So I just have it normally where it's plugged in there, and then the other side goes to the hot end, of course. But just for demonstration, I have that still off. I don't know if it picks it up, but down there's a little light that lights up. So as you see, motion is causing that light to flicker, and then there's no motion, there's nothing. So as there's motion going through, every time that's going on is that, let's see, I'll get in the middle. So that is when one of those little fins is blocking the light, and then that's when the light is being allowed to show through. And so that's what's going on. So you can see it's click off on as the filament moves. And so that's the signal that's also being sent to the controller board. So that's how it knows that something's going on. And of course, there's filament in there, so it's also receiving the all good that's filament. So the motion part of it doesn't really matter if the light's on or off when it's not moving, if you're not telling it to, because that's just a visual confirmation that something's happening. So it's showing me that the sensor is plugged in right and working. And we come over here to my machine so we can query these and actually show you that they're working. The way to do that, first let me show you. You have to get the name. I forgot to point that part out. So when you're in your configuration, so this is how I have mine set up on this machine. So like I said, exactly how I showed you on the other one. Just different pins. But the first part, when I was saying the filament switch sensor, that's what sensor it's listening to. But the next part, after your space, is whatever you want to name it. It can be anything. It doesn't really matter. This is just a name. So the first part is what it is, and then after the space, whatever you want it to be called. But that's important to know because this is what we're going to use to query. So that name, we have switch sensor and encoder sensor. Those are what we use to actually ask to say, is it working or not? So to do that, we come into the console. Oops, not the height map. There you saw my ugly bent bed. So the way we do that is, I've already typed it in here, of course, but it's query _ filament _ sensor space, and then sensor equals, and then whatever your name is. So like I said, I've had encoder sensor, for instance. Let's see. Get the light. I don't think the light needs to be on, but I'm just going to make it to where the light is on. And then I hit enter, and it's going to look for it and see filament detected. So it thinks everything's good. The encoder one, I'm not sure exactly how well, because if you have the light off, I think it does also still say that. Mainly because I'm not giving it a command to move. So it's kind of in a limbo situation. It's basically saying that I haven't heard anything bad yet. But with the other one, the filament switch sensor, so this is for the runout switch. So right now there is a piece of filament in there. So I run that and it says filament detected. And if I remove it, it should, if I did this correctly, run it again. Now it says not detected. So that's how we know it's working properly. Pretty simple setup. That is the gist of it. Not really complicated, as you can tell. Of course, like tradition, I have a very long video explaining all of it and all the good stuff there. But if you have missed something or don't quite understand, of course, leave comments down below. I will definitely help you out as best as I possibly can. And hopefully you enjoyed this. And again, thank you to Bigtreetech for sending me this sensor to check it out. Can I recommend it? Absolutely. I think it's great. It's easy to set up, as you can see, works exactly as expected. So yeah, I mean, it's a plus plus. I can't really see anything wrong with it. It looks good. It's tiny. It's light. It can go anywhere on your printer that allows the filament to go pass through. I haven't noticed any changes in the way it prints, so it doesn't seem to hinder any issue with motion. Maybe if you have a really weak extruder, it might, I guess, because it does, have to pull one extra thing. But honestly, it doesn't seem to cause or be that hard to pull it through by hand either. So um, maybe that's one thing to keep in mind. If you have a really weak extruder, you're already having issues, probably don't want to add another thing in line. Otherwise, I mean, the thing works great. I'm pretty happy with it. I want to get more from my other printers, so it is that good in my opinion. They actually did not tell me I have to say anything. They did not even tell me you need to give any kind of review. They just said, hey, you want one of these? We're going to be sending them out. So yeah, that was it. But also another thank you to PCBWay. They are sponsoring this video. Huge help. Thank you, thank you, thank you. And thank you to all my new subscribers. I see things kind of getting some good traction here on my channel. It's really really nice. Hopefully, if everything went well, my audio recording is a little bit better. I'm working on trying to get the channel cleaner and more direct and easier to follow along with. So hopefully that's being relayed, and that is my goal, is to get things better quality for all of you out there, to anybody looking for help. And yeah, so again, like I said, thank you to everybody. You guys are great. Leave the questions down below if you have any, or any just kind of comments, questions, or suggestions for new videos, any things you guys want to learn more about. So I'm always reading my stuff, and I try to respond to everything as possible. So again, thank you, and I'm going to let you guys go now because I'm starting to talk too much. Happy printing. Bye.